So in this video, I'm going to create a HELM chart, which will enable me to be able to distribute my application along with all its dependencies so that anyone can download the HELM chart and deploy the application into a fresh Kubernetes cluster in one step. So I've built a simple microservice application with Spring Boot and deployed it to Kubernetes, and I've been installing it with YAML. Now the microservice application needs ingress, it needs an ingress controller installing, and it also has a MySQL implementation deployed in the Kubernetes cluster. So a better way of doing things is HELM, which is a package manager for Kubernetes. So let's get straight into it. I'm going to create a new package in Eclipse or new general project. And I'll call it MSHW, which is the name of my application, microservice hello world, and MSHW HELM. So you can get HELM from helm.sh if you need it. That comes as a executable, so you need to add it to your path, then you should be able to use HELM. So I've already installed HELM here, and I'm CD'd into my directory that I've just created of my new project, MSHW HELM, and I'm going to create a new empty HELM chart. So I do HELM create, and I'll call it MSHW HELM chart. Then we can see we have a new folder, MSHW HELM chart, and if I look at what's inside that, we have a couple of folders, charts and templates. We have a values YAML file and a chart YAML file. Now we need to customize these elements to create a HELM chart. First, we're going to create a HELM chart for our application as it is, and then we'll add the dependencies to it later. So I'm just going to refresh this here so we can look at it in Eclipse. So we have the charts folder, which is currently empty. We have a templates folder, which has some bits of YAML with some markup that we'll look at how that works in a bit. And then we have the chart YAML file, which just contains some metadata, and a values YAML file, which contains some values that we can add in there. So we're going to customize all this. The first thing I'm going to do, I'm going to clear the YAMLs file completely, and I'm going to clear out everything from the templates folder. So we're going to start from scratch, making a new HELM chart. And in the chart.yaml, we have metadata. So we have app version, type, application. I'm just going to change the description and say HELM chart for microservice hello world application. And I'll just leave everything else as it is. Now to create a HELM chart, we put our YAML into our templates folder. Now we've got two microservices, one MSHW and one MSHW caps. So I'm just going to create two folders in the templates folder, one for MSHW and one for MSHW caps. How we organize our templates folder is totally up to us, but I like to have the different microservices separated by folder, and then I create a bunch of YAML files inside these, one for each type of Kubernetes element. So I'm going to create a YAML file for each type of element we have. So I'll create a file. We have a config map.yaml. We have a deployment.yaml. We have a service. And I'll just go on creating a config map for each thing that we have in our YAML file for our original microservices. So like I said, how we organize this is totally up to us, but I've decided to put ingress, namespace and persistent volume in directly in the templates folder. And then for my first microservice MSHW, we have a config map and a secret, as well as our deployment and service. And then we have a persistent volume claim, which is a claim to this persistent volume. And then my second microservice is very simple. We just have a deployment and a service. Now I'm going to take the YAML from my original files and paste the bits of YAML into these separate files. So I'm going to take the YAML from persistent volume and put it into the persistent volume in the Helm chart, and I'm going to carry on for each of the elements until I've got all my YAML from the original YAML files into my Helm chart. Okay, so now I've got all the YAML in my separate files in my Helm chart. Now if I go to my terminal and I do HELM Template and then the name of the Helm chart, we see the YAML that it would create if we deployed the Helm chart, and we can basically see we're back to our original full set of YAML. The one thing it has done is put a comment in each section saying the source file that it's come from. So if I wanted to, I could put that into a file, and then I could apply that YAML to the Kubernetes cluster and it would install things just the same. But with Helm, it's a package manager and it's designed to install things into Kubernetes, so we do the job properly. So I'm going to delete my deployment now, kubectl delete. Everything's installed in the namespace, mshw namespace. So I delete both of my microservices there, and also there's a persistent volume. I'll also delete that. kubectl delete pv mshw pv. So we're now, if I look at what we have in Kubernetes, I still have MySQL installed, and we still actually have the Nginx controller installed. We can see that in the namespace we have ingress Nginx, but my microservices are completely cleared down. So now to install my Helm chart, I'm going to do Helm install, give it a name and tell it the Helm chart, and that's it. Helm is installed everything. So now if I do kubectl get namespace, we see we've got the mshw namespace. And in the namespace we have two microservices, the services, the deployments and the replica sets. We also have a persistent volume. This is a persistent volume for the NFS server in the microservice, and that's the one for MySQL. And we also have a persistent volume claim for the microservice. So I pull up a web browser and do mshw.com and just confirm that our microservice is still working. It's got 4 functions. One is to just output a message, one is to output a secret, one is to read from the MySQL database, and one is to count up using the NFS server. So everything's still working. I could do Helm list to see what we have installed. My release is the MySQL server that I installed in a previous video, and mshw is our microservice that we've just deployed. Now we can do more with Helm than just deploy YAML like that. We can also use the values file to define custom values that we then insert into our YAML. And if I give you an example of that, I think you'll see how that can be a powerful feature. So I have some values here. It's in standard YAML format, so remember that indentation is very important. But for the mshw microservice, I've got a number of replicas. I'll set it to 3, and the container port that runs on 8085, and my mshw caps, the second microservice, I'll say replicas 2, container port for that is 8086. So now in my YAML I can use these values. So in the deployment of my main application in replicas here, I can say 2 open curly brackets values, which is the file, and then mshw replicas, and here's the container port. So values mshw container port, and also the service uses the container port, and similarly in the second microservice, MSHW caps replicas, and MSHW caps container port, and again in the service that uses the container port. So now if I go to my HELM template again, I can look at the YAML and I can see that we have replicas 3 and container ports have been copied across from the values in the values YAML file. And if I now do HELM upgrade MSHW, we should be able to see now that our replicas have increased. We did 1 replica from the straight YAML, but in the values file I defined 2 replicas of this microservice and 3 replicas of that one, and of course everything is still going to work. Now we can do elements of Golang scripting in our YAML files, and here's some examples of that. So for example, we could have a values defined, but we could define a default value of 3. This example 2 would make the value as defined in the values file lowercase, and we can chain things together as well. So for example, we could have a repo name defined in the values file, we could have a default value and we can make sure it's lowercase. We could have conditionals, so here we're saying if values environment equals dev, then include -dev onto the end of the image name. We could also have values development defined as a boolean, so we could just say if values development add dev onto the end of the image name. And we can do if values development dev else prod. So this is just a very quick example, but there's various bits of scripting that we can do in our YAML files if we want to. Now another thing we can do is we can define templates. So within our templates folder, I can define a template file and then we can include the template file into our YAML file. So that's quite straightforward. Let's just say if I wanted to take a section of my YAML out. So if I take this bit from my config map and then in template, I'll define a new file. And I think we can call this what we want, but the convention is to have an underscore. I'll call it common config.tpl for template. And I'll paste it into my template file. And above that, I'll say define MSHW common config into curly brackets and then end and 2 curly brackets. And then back in my original config map, I can say template MSHW common config. And if I now do HELM template, and find the config map, I can see that that's worked. It's taken this bit out of our template file and put it into our config map. Now Golang would normally put a new line before it, and we don't want that in the template, so we have to put this minus at the start to make sure it doesn't put a new line character. And this refers to prefixes that we would use if we're inserting values into here. We'll have a look at that in a minute. Now I'm going to just test that this is working. So in my template, I'm going to change the name of the hello world message to hello world from HELM template file. And then I'm going to HELM delete MSHW. So this is one of the good things about HELM, is I can delete the whole implementation in one go. If I do kubectl get pv it's deleted by mshw persistent volume, and kubectl get namespace, it's deleted by mshw namespace. So in one line I've been able to delete the whole application that was installed with HELM, which is pretty useful. Now I'll install the whole thing again. HELM install mshw, and now if I get my web browser and reload, it's just going to take a moment to get going. There we have hello world from HELM template file. It's in capital letters because the second microservice is capitalizing it. But that shows that we've applied our new config map to the deployment. Now, how much this is indented in our template file is important, because when we insert it into our YAML here, the indentation here doesn't matter at all, but how much it was indented in the template file is how much it will be indented in the YAML file, the final YAML file. And YAML is very fussy about indentation, so that's not ideal, because we may want to have a template file, we may want to include it in more than one YAML file, and we may want it indented at a different level in each YAML file. So it's better to use include rather than template. And with include we can pipe it and we can say indent to. Then in the template file itself we should remove the original indentation, so we're specifying how much we want it to be indented in the YAML when we include it. So now if I do HELM template, and we find the config map, we can see it's indented as it should be there. But if we were to change this value, I'll change it to something ridiculous. There we can say there we've indented it 20 spaces. The indentation between these lines of course is still relatively as it is in the template file, so that this line is 2 more deeper than the top line, but we can control the indentation by using include like that. So I'll put it back to 2, but if we wanted to include this section in another YAML file but with a different level of indentation, then we could control it by using include. Now I mentioned this before, let's have a look at how this works. I'm going to define a new common service template. So new file, underscore again, common service template. Now, if we look at our services, we have a service for each microservice. They're quite similar. If I flick between the two, we can see that the only thing that's changing is the name, the port, the target port, which is defined in the values file, and the app. So I'm going to create some values to define these 4 different things. So in my values file, we already have sections for MSHW and MSHW caps. In there we have replicas and container port. I'm just going to add the other things. So you have service name, service port, and app name, and the same for the second microservice. In my common service template file, I'm going to define the service like this. So I'm defining MSHW common service, and then for the name, the port, the target port, and the app, I'm specifying only the .service name, .service port, .container port, .app name. So I'm specifying these things, and then for my service YAMLs, I can replace them completely with just the one name, but now instead of dot, I'm saying .values MSHW. So this is the prefix for the values that are going to get inserted into our file. So here I'm saying for example, .service name. So in the file, in this service file, the value that's going to get inserted into the template is .values.mshw.service name, which of course is .values.mshw.service name. So I'm defining the services like that and telling it the prefix for its values from the values file. And similarly for the other service, in just one line, I can define it to use the values from values mshw caps, which is there. Now if we do HELM template again, we should see that we've taken our services. These are 2 services defined here, and we've templated them and just defined them in one go. So you can imagine how that could be useful if you have large sections of YAML that are just repeats. It's likely that you might have many microservices and maybe the service definition is very similar for each one, and you just want to template it and then copy values in. So that's quite a powerful feature of HELM there. Now I'm just going to check everything's working, so I'm going to HELM delete mshw, make sure everything's saved, and HELM install mshw with our HELM chart, and just confirm that everything is still working. This, I'm just getting this because things are just still starting up in Kubernetes. There, so the read is working, the secret's working, the database is working, and the counter on the NFS server is still working. So that's good so far. We've built a HELM chart for our application, but there's 2 things that our application is dependent on. It needs an Ingress Nginx controller, and it needs MySQL to be deployed. As if I look in kubectl get all, we have MySQL deployed there, and if I do kubectl get namespace, we have an Ingress Nginx controller installed. So if I gave my HELM chart to you now and you tried to install it, the application wouldn't work because the dependencies aren't there. But with HELM we can deploy all our dependencies in our HELM chart. So let's have a look how we do that. Now when I deployed MySQL, I got it from Artifact Hub, and it was the Bitnami package as defined here. So I'm going to go back to that page and click on install. I need to make a note of the repository, which is charts.bitnami.com/bitnami, and the version number, which is 11.117, and the chart is called MySQL. Similarly in Artifact Hub, if I find Nginx Ingress controller and click on install, I have the same repository there. The name of the chart is Nginx Ingress controller, and the version is 11.4.3. Now I'm going to go into my chart YAML of my HELM chart, and I'm going to add a dependencies section at the bottom that looks like this. So we want MySQL 11.1.7 from charts.bitnami.com, and we want Nginx Ingress controller 11.4.3 from charts.bitnami.com. And now we're going to add the HELM charts for these. We're going to download them from Artifact Hub and add them to our HELM chart. In one simple step, we type HELM dependency update and mshw HELM chart, and it will download the HELM charts for those things and add it to our HELM chart. It says update complete, happy HELMing. Now if I refresh my folder, if I look in the charts folder, we now have zipped up copies of those HELM charts. And if I go back to Artifact Hub, I can look up values that I can define in my values file to override things that are defined in the HELM chart. Now for Nginx, I need to override the namespace because my original Nginx namespace was in Ingress Nginx namespace, so I need to make sure it's in there. And for the MySQL chart, I need to make sure the password is the same as the password that I have defined. So that's auth password. I need to make sure that's the one that I've got in my application talking to the MySQL installation that I've currently got in Kubernetes. And also auth database. This is a name for a custom database to create. So when I installed MySQL, I created a database called MSHW, but I can do that in my YAML file. Now, how to use these values is really on a per chart basis. You do have to read the instructions and work out how to do things. There's no way around that really. You have to go through the instructions. But in my values YAML file, I'm going to define those things there. So this is the name of the database, the password that I'm using from my application prod properties, and the namespace for Ingress Nginx. Now again, there's no easy way to find out how to do this, but I've tried this already and I've ended up with 2 errors. One of the errors, Ingress Nginx is not installing a namespace for itself. So in my namespace file, I need to add a namespace. I suppose because I've specified a custom namespace in my values file, I just need to create that namespace for Ingress Nginx and just separate them with the 3 hyphens there. Now when I installed MySQL the first time around, I called it my release. That was just from the default values in the instructions for the Helm chart. I actually want to call it MSHW, and that name MSHW, when we do Helm chart installations, I do Helm install MSHW and the name of the Helm chart. That's the release name there. Now I don't want to start calling my application my release, so I'm going to rename it to MSHW. It would be convenient if I had that in a config map, but I have it in my application properties file, so I'm just going to rebuild my application now. So I'm going to run as maven install, rebuild my Docker image, and upload that updated Docker image to Docker Hub. Okay, so I'm just pushing that updated image to Docker Hub there. Now what I'm going to do next is completely reset my Kubernetes cluster. So I'm going back to a fresh installation of Kubernetes. That's going to take a few seconds to happen. But when I come back, I'll install everything from the Helm chart and hopefully everything will work. Okay, so my Kubernetes cluster is reset. If I do kubectl get all, I'm back down to a fresh Kubernetes cluster. So I don't have the Ingress Nginx installed, I don't have MySQL, I don't have anything. Now I'm going to do helm install MSHW. I need to just get back to the right place. Okay, so I'm now back to my Helm chart directory. I'm going to do helm install MSHW Helm chart, and that's deployed. Now if I do kubectl get all, I can see we've got our MySQL installed. If I do kubectl get namespaces, I've got Ingress Nginx, and if I do kubectl get all in MSHW namespace, we can see everything is running. It seems to be running. So let's see if it's working now. Pull up a web browser, MSHW. That's working. The secret is working. The counter is working, so we're connected back up to the NFS server. And read, of course we've got a fresh MySQL, so we've lost the data, but the database appears to be working. If I write something and then read it again. So the database working. So the whole application is working again, but we've installed it with one line of terminal code, and that is just HELM install, and we have it deployed as a package which we can delete in one go and reinstall or upgrade in one go. So that's much more convenient. So now going forward, I can forget about my original YAML files and I can maintain the installation of the project as a HELM chart. So I think you can see that's much more convenient. So that's it for now. Thanks for watching.